Hello everyone. This is Dr. N.B. Mahesh Kumar, Associate Professor, Department of Computer Science and Engineering, Hindustan Institute of Technology, Coimbatore. Now I'm handling a subject Internet of Things. Here we are going to discuss about the topic IoT Sensing. Here what are the course learning objectives of the today's topic IoT Sensing. First objective, we have to list out what are the silent features of sensors and transducers. Second course learning objective will be we have to differentiate between sensors and actuators. Third course learning outcome will be we have to characterize the different sensors and different actuators. Next, course learning outcomes. First outcome will be we have to identify the basic components and what are the functions of different sensors and actuators. Second course learning outcome will be we have to explain the principles of operation for the common sensors and actuators. A third outcome will be we have to solve specific engineering problems using appropriate sensors and actuators. Third outcome will be for different sensor and actuators we have to compare the performance characteristics. Next outcome will be we have to assess the suitability of different sensors and actuators for a particular applications. Last outcome will be we have to design a comprehensive sensing and actuation system for a real world applications. Next, what is the definition of a sensor? Sensor detects or it senses what are the changes in the environmental conditions, or it may be a state of another device or a system. Then it will forward the collected information to the cloud, and then it process the information in a particular manner. So here sensor is nothing but device which will detect or measures a physical property, and it records the sensor values, and also it indicates or otherwise responds to it. Here sensor may perform some important input functions by sensing or feeling the physical changes in a system, mostly responded to the stimuli. For example, in a temperature sensor, heat is converted to electrical signals. For example, in a barometer, atmospheric pressure is converted to electrical signals. So these are the two examples for a sensor. Next one, transducers. Transducer will convert one form of energy to another form of energy. For example, in a sound system, there is a microphone. Microphone also called as input device. So this microphone converts sound waves into electrical signals. Then this electrical signals will be forwarded to the amplifier. So amplifier will amplify the process. And a loudspeaker is an output device in a sound system. So loudspeaker converts electrical signals into sound waves. Next, what is the difference between sensor and transducer? Here the word transducer is nothing but collective term that will be used in both sensor and actuators. Here sensor is used to sense a wide range of different energy forms. For example, electrical signals, radiant energy, movement, thermal or magnetic energy. Here actuators mainly used to switch the voltages or currents. Next, what are the features of a sensor? First feature is sensor will be sensitive to the measured property. For example, temperature sensor used to sense the temperature of a room. Second feature is sensor will be insensitive to any other property. For example, temperature sensor sense the temperature, at the same time it does not bother about light or pressure in the room. Third feature of a sensor will be it does not influence the measured property. That means, so we can measure the temperature using a temperature sensor. This temperature sensor does not reduce or increase the temperature in a room. So next, resolution of a sensor. Resolution sensor is defined as the smallest change it can detect in the quantity that we are going to measure. Resolution of a sensor with the digital output is usually the smallest resolution. If the resolution of a sensor is very more, then more accurate we got. And also accuracy of a sensor does not depend upon resolution of a sensor. Next, classification of a sensor. Sensor can be classified into analog or digital based on the output. Sensor can be classified into scalar or vector based on the data type. Next, definition of an analog sensor. So most of the analog sensor will produce a continuous output signal or a voltage. So this will proportional to the quantity being measured. Physical quantities such as speed, pressure, displacement, temperature, strain, all are called as analog quantities. Here all the quantities will be in a continuous in nature. For example, using thermometer or thermocouple, we can measure the temperature of a liquid in a gases. This will continuously respond to the temperature changes while liquid is heated up or cooled down. So next definition is a digital sensor. Digital sensor produce discrete digital output signals or voltages. That means there is a digital representation of the quantity being measured. Digital sensor always produce binary output signal in the form of ones and zeros. One will be on state, 0 will be off state. Here in digital sensor produce a digital signal that will produces discrete values. So here discrete values also known as non-continuous values, which may be output as a single bit. It is called as a serial transmission, or otherwise combine the bits in order to produce a single byte. So this transmission is called as a parallel transmission. Next is scalar sensor. Scalar sensor will produce output signal or voltage. So this will generally proportional to magnitude of the quantity being measured. Physical quantities such as color, temperature, pressure, strain, here all are called scalar quantities. And also scalar sensor, their magnitude is sufficient to convey the information. For example, using thermometer or thermocouple, we can measure the temperature of a room. Here which responds to temperature changes irrespective of the orientation of the sensor or its direction. Next, vector sensor. Vector sensor produce output signal or voltage. So this will generally proportional to the magnitude, direction and also orientation of the quantity being measured. Here physical quantities such as sound, image, velocity, acceleration, orientation all are called vector quantities. Here magnitude of the vector sensor is not sufficient to convey the complete information. For example, by using accelerometer, we can measure the acceleration of a body. So this will give the components of the acceleration of the body with respect to x, y, z coordinate axis. Student, now this is a time to attend the MCQ questions. You can scan the QR code to attend the MCQ questions. First one is a smart home. In smart home, we are using motion detector, temperature sensor, humidity sensor. Here actuation will be automatically we can control the light, and the thermostat will adjust the temperature. Then window blinds opening or closing based on the weather conditions. So in a smart home, we are using motion sensor that will detect a person entering a room. This is known as sensing. System automatically turns on the lights. This is called actuation. So if no motion is detected for a certain period, lights will be turned off. Next, summary of the today's topic. Sensing refers to gathering data from the environment through various sensors. Example, temperature sensor, motion sensor, humidity sensor, pressure sensor. And also, sensor will capture real-time information about physical parameter. Here, actuation involves responding to the sensed data by triggering actions through actuators. Here, various actuators are motors, lights, valves, and switches. So, actuators will enable devices to physically change their state, or it can perform different tasks based on the sensor inputs. Next, what are the outcomes achieved after learning the topic IoT sensing? First outcome will be understanding. Outcome will be how IoT sensing and actuation function and their significance in real world applications. For example, a student may explain how smart home system uses motion sensor to control lights in a room and also create a security alarms. Here objective will be a student may describe the role of sensors in detecting environmental changes and how actuators will respond to those changes in the room. Next outcome will be applying. So using IoT sensing and actuation principles, we may solve real world problems or we may design basic IoT systems. Here students may create IoT based system. In IoT based system, we are using soil moisture sensor. So soil moisture sensor will automatically triggers irrigation system for optimal plant weathering. Here objective will be we can design IoT system that uses sensors and actuators to automate tasks in a home or industrial environments. So next I will give exercises. You solve it in your home. First one, understanding level. You may describe what is the role of temperature sensor and actuator in a smart thermostat. Second level will be application level or applying level. Student, you must design a simple IoT system. In that IoT system, we are using a sensor. That sensor will detect light levels, and also we are using actuator in the IoT system. That actuator will control opening and closing of a window. So third one is analyzing. Analyze the relationship between data accuracy from sensors and the presence of actuators in a autonomous vehicle system. So thank you.